We start with the long polynomial m, trying a first grouping strategy in the left column. We apply the trick of adding 1 and subtracting 1, looking to complete perfect square trinomials. We group the first terms, factoring out the negative sign to form a squared minus 2a plus 1. This compresses into the binomial a minus 1 squared, and we try to do the same with the letters b and c. We try to apply difference of squares between c plus 1 and a minus 1 to look for common factors. However, the loose terms like 2ab prevent us from advancing, marking this path as wrong with a red X. We move to the second central column and restart the problem with our original expression m. This time, we strategically group minus a squared plus 2ab and minus b squared at the beginning. We extract the negative sign from these three terms to reveal a perfect square trinomial inside. We factor it directly, turning it into the binomial a minus b, all raised to the square. We move the letter c squared to the left to form a clear difference of squares. We apply the formula, opening brackets, to place the sum of the bases multiplied by the subtraction of the bases. By removing the inner parentheses, we get c plus a minus b multiplied by c minus a plus b. Now we focus on the final three terms of our line, which are 2a minus 2b plus 2c. We extract the common factor 2 to leave the expression a minus b plus c inside the parenthesis. We underline with yellow color the c plus a minus b at the beginning and the a minus b plus c at the end. We realize that both trinomials are exactly the same common factor, just in a different order. Moving to the third column, we extract this large common factor, c plus a minus b, to the left. We open brackets and place inside what we have left over, which is c minus a plus b, accompanied by the positive number 2. We remove the brackets to clean the expression and successfully finish our factorization with the green check.